Carbon sequestration is the process of capturing carbon dioxide from the atmosphere and storing it so that it doesn't continue to act as a greenhouse gas. Recently, this process has gained a lot of attention as humans are developing technologies to artificially pull carbon out of the atmosphere and store it. And while this solution holds some potential to reduce the risk of runoff climate change, most experts acknowledge that reducing the burning of fossil fuels must also be prioritized. But besides artificial carbon sequestration, this natural process has been happening for thousands of years as plants, animals, and water bodies absorb and incorporate atmospheric carbon into themselves, storing it away in what are called natural carbon sinks. And while most of us might think about forests and trees as the major carbon sinks on land, the huge potential of ocean ecosystems to store carbon is just starting to be explored. And the term blue carbon has emerged to describe the potential of ocean and coastal natural carbon sequestration. In today's episode, we'll explore some of the underappreciated coastal ecosystems that have an important role in carbon sequestration, the role coastal communities and First Nations play in restoring these important ecosystems, and how you can engage in protecting natural carbon sinks in your own community. Hi everyone, and welcome here today to the first 2022 BMSE Climate Action Series episode. Whether it's your first time here or you're back for more, welcome. My name is Aneri and I'll be your host today. We've got an exciting lineup for you as we dive into the world of blue carbon, coastal restoration, and how this all fits into the climate solutions movement. Our first guest today is Dr. Sophie Comer-Warner, a biogeochemist working across all kinds of aquatic landscapes, from streams and rivers to coastal wetlands. Her research focuses on carbon and nitrogen cycling, and particularly how future global change will affect greenhouse gas emissions and nutrient pollution. Sophie has a master's degree in oceanography from the University of Southampton and a PhD in aquatic biogeochemistry from the University of Birmingham. She is currently a postdoc research fellow funded by the European Union, investigating the effect of future global change on climate feedbacks and nutrient filtration potential in salt marshes. Thanks for joining us, Sophie. Please go ahead and start your presentation.
Okay, so Anna asked me to just quickly kind of go through how I got to this stage in my career. And I think if there's anybody listening who thinks they're doing the wrong subject at the moment, then this could give them some hope. So I first thought that I should go to university to do something that would make me the most money. So I did chemistry, a 4-year undergrad, and I really did not like it. But in my third year, I got to do study abroad at the University of Maryland. And here I took an atmospheric chemistry and climate class. This really introduced me to a lot of earth system and environmental science, and I kind of got hooked. But I was already so deep into my chemistry degree that I just had to finish it. So after that, I went to the University of Southampton to do my oceanography degree. This is pretty cool because it's the Oceanography Centre of the UK. So here all the research vessels leave from, so you can go and tour them and see them loading and everything. And then after that, I did a PhD in Birmingham, where I looked at carbon and nitrogen cycling in freshwater systems. And then in the end, I came back to do fellowships and ended up in coastal wetlands. So I've been working at McGill University and the University of Birmingham. This has allowed me to look at, this is a photo I took of some mangroves I worked on in Vietnam, and also salt marshes of Quebec and Louisiana. So I think even though I hopped around a little bit, the chemistry degree gave me some really good skills for the lab work that I do and the manipulation experiments. And then taking that freshwater side as well as the oceanography side and ending up in the coastal zone has actually been pretty useful in terms of knowledge. So yeah, if you think that you were kind of wish that you did something different, I think it's okay. And we can maybe, there's some hope for going forwards into the field that you're aiming for. So before I got into carbon sequestration, I wanted to just kind of quickly go over some of the carbon cycle of the coastal ocean before we did that. This paper is a little bit old now, from 2013, but it's in Nature, so it's shorter and more easy to digest. And I think it gives a really good overview if anyone's interested in finding out more. So when we think of the estuary environment, I'm sure everybody knows that we think of the river coming in to meet the sea, and there's mixing in that estuary. And we usually see really extensive tidal wetlands in these environments. So here, this diagram is set up exactly the same way. So we have the river water on the left and then the sea on the right. And just so I don't lose anybody immediately, the acronyms are the dissolved organic carbon, DOC, which is a smaller sized particles, the particulate organic carbon, which are the larger particles, and then the dissolved inorganic carbon, which is carbon dioxide and the carbonates. So I'm sure most of you can think, if we think of carbon coming in and out of the estuary, of the terrestrial carbon in the freshwater, coming down the river, and then what is flowing out into the seawater and into the shelf. But there's also that exchange, so you get marine carbon coming back into the estuary. Then some things you maybe haven't thought of is the coastal wetlands. They're very high in carbon, so they can introduce carbon from the sides of the estuary. And then also we get extra carbon in submarine groundwaters and sediment pore waters. Now we also have some internal cycling, as you might expect. So we can have carbon dioxide uptake through photosynthesis and primary production, and then we get outgassing from respiration and photooxidation. And the balance of these really gives how much carbon is going into the seawater and onto the shelf from the estuary. And then we also have another thing that some people don't think about, this kind of exchange with the sediment. So you could have particles aggregating together and then settling out into the sediment, but then that sediment can also be resuspended and get that carbon back into the water column. But in terms of what we want to talk about today, back to this photo that shows these really extensive coastal wetlands, that is really the portion of the estuary that we are thinking about in terms of that natural climate solution. So here is a really good paper from 2019. It's on the future of blue carbon science. And I think if you have any interest in this, it's a really good paper. It gives a good overview of the subject area, but they also highlight where they think the field is going and where the big questions are still that remain to be answered. So if you are thinking of writing proposals for grad school, then I think this would be also a good place to go and a good resource to kind of see if your ideas map onto this or to get some more ideas. So blue carbon, what do we mean by this? So we started off everyone thinking of terrestrial forests, and that was coined as green carbon. Then we started to think of what about these marine systems, and that's where blue carbon came from, kind of in opposition to green carbon. So this includes tidal marshes, mangrove forests and seagrasses, but also the coastal plankton and deep sea carbon. So the definition is the organic carbon that is captured and stored by the oceans and coastal ecosystems. When we think of blue carbon, we are usually thinking of those vegetated coastal wetlands, the seagrasses, the mangrove forests, and the tidal marshes, more so than the plankton and the deep sea carbon. So what is so special about these environments? They give us a ton of ecosystem services, but in terms of the carbon, they have very high rates of productivity. They are some of the most productive ecosystems on Earth, and they also have high rates of carbon burial. And that means they can store a lot of organic carbon, both in their plants, so that can be above ground in the grass, in the stems, in branches and leaves, and also below ground in roots and rhizomes, and also in the soil itself as soil organic carbon. And then here's to really highlight that kind of critical storage capacity that they have. And one thing that's really important to note is they only take, as you probably imagine, they only take up a small amount of the Earth's surface, but they have a really big impact for their habitat size. So 83% of the global carbon cycle is circulated through the ocean, and coastal habitats cover less than 2% of that total ocean area. But then these coastal habitats account for approximately half of the total carbon sequestered in ocean sediments. So they are really storing a ton of carbon and having, like I said, a really big effect on the carbon cycle, given their really small aerial coverage. So just in case people are not so familiar with these systems, they can be these really big systems and very extensive. So here are some mangroves. This is a mangrove fringe channel in Australia. And mangroves, they tend to store some of their blue carbon above ground because they are forests. They have a lot of more capacity to store carbon in the trees, but they also store a lot of carbon below ground. And here's what they look like up close. This is just a dwarf species, but you can see this kind of classic root structure that we see. So they have very extensive roots, and that helps to keep them grounded during the tidal cycles. And then here is, these are called pneumatophores, and that helps the roots to get oxygen from the atmosphere so it can have exchange of gases. That's how they can really survive in these very wet environments. For tidal marshes, again, this is a salt marsh in Virginia, and you can see it's a very big system, and it looks kind of like a meadow from far away. Maybe you wouldn't realize that it was the salt marsh originally. And for salt marshes, they store most of their carbon below ground. In a lot of places, they die off during the year. So where I work in Quebec, the salt marsh is actually frozen for 4 or 5 months of the year. And so most of that carbon is below ground. And up close, they kind of look just like any grasses. This is one species, Spartina patens, that lies kind of flat. And then this is Spartina alterniflora in the low marsh, and that grows kind of straight up. Now with seagrasses, we also get these huge meadows. This is in Australia, and they have some of the world's largest seagrass meadows. And for seagrasses, they store almost all of their blue carbon below ground. So more than 95% of their carbon is stored in the soil. And again, they just look like grass that's growing underwater, in case you've not seen them up close. And so I mentioned the really high sequestration rates and burial rates in these systems. So this figure just shows the carbon burial rate. So it's grams of carbon per meter squared per year. And this is a log scale, so every time you go up the x-axis, it's 10 times as large. And these are probably the forests you've normally thought of, these terrestrial forests. And this is the carbon burial rates in those. And then you can see these coastal wetlands we're talking about, the carbon burial rates are over 10 times higher. So they really do have that high rate of carbon sequestration that I've mentioned. And this is another figure showing the above versus below ground carbon storage, and also how high amounts of carbon are stored in these systems. So you see these terrestrial forests, they have a much lower amounts of carbon being stored. And here you can see that for the tidal salt marsh and the seagrass meadows, as I mentioned, most of their carbon is below ground in the soil. And with mangroves, they have a much larger proportion of that total blue carbon that is stored above ground in the living biomass. And then where are these wetlands distributed globally? Here we have a figure of the global distribution of them. The black is salt marsh, the blue is seagrass, and the green is mangroves. You'll see that the green is all located in the tropical region. So mangroves grow closer to the equator. And as we move polewards to higher latitudes, these wetlands transition into tidal marshes instead. Seagrasses are found on every continent except Antarctica, so they are very widespread. And in the tropics, you get a higher species diversity of seagrasses. In some areas, you can see you get 2 kinds of wetlands, or even some areas there's 3 kinds. But if you see here in Southeast Asia, that is where most of the world's mangroves are, and they also have a lot of seagrass coverage. And so salt marshes a lot of the world's salt marshes are in America and Canada. This is another depiction. I don't think it's very clear because they didn't use any color, the difference between mangroves and salt marsh. But I just wanted to bring this up to think about why mangroves grow, where they are. So here, these two lines are the 20-degree isotherm. So in the sea surface temperature, anywhere between these lines is higher than 20 degrees. And that's where the mangroves grow. So they grow in this higher temperature places. And where you get this isotherm, where it crosses through the continent, kind of, if you were to join it up, then you get both mangrove and salt marsh existing together. So in the south coast of Australia, and then where I just showed around Mexico and the north of the Gulf of Mexico. So I just wanted to show this video in case people are not so familiar with what the tidal flooding looks like. So mangroves, they do not get completely covered by water because they are trees, so just the roots go up and down. But in these salt marshes, so this is one in Georgia, you saw that at first the soil was exposed at low tide. And then as the tide moves in, it starts to get flooded and it moves up the grasses. And eventually you're going to see that actually in this part of the marsh, this is the lower part, the grass gets completely covered by the high tide. And then, you wouldn't even know probably that there was a marsh there. If you went at high tide, it might just look like open water. So they have a lot of tidal flooding, and this really affects how anaerobic their soils are. So it stops a lot of oxygen diffusing down. So now if we think more of those ecosystem processes that are making this happen. So we get sequestration through photosynthesis, a lot of carbon dioxide being taken up from the atmosphere by the plants. And then we get a lot of that carbon storage that I mentioned. So burial of dead leaves, branches and roots in the soil, and also the live below ground biomass. And because the soil is low in oxygen from that tidal flooding we just watched, we get a very slow breakdown of organic matter. We do get some respiration from the plants, but that really just accounts for a very small portion of the fixed carbon being released back into the atmosphere. Then I wanted to think about soil processes. So we think of the amount of carbon in these systems we take from carbon stocks, but there are also processes in the soil that have reactions that kind of transform carbon and nitrogen, and these can release the greenhouse gases, N2O and CH4. So these are very potent greenhouse gases. SGWP stands for the Sustained Global Warming Potential. And you see that N2O is 270 times stronger as a greenhouse gas than CO2, and methane 45 times. So the release of these gases can actually offset some of that climate mitigation potential of these wetlands. This is a lot of chemistry on this slide, but I'm just going to highlight something. So the top process is aerobic respiration, and this takes you through the different anaerobic respiration processes and the energetic favorability. So here you'll see sulfate reduction is above methanogenesis, which is methane production. So if we have a high salinity and a lot of seawater bringing in sulfate, we expect methane emissions to be negligible. So that's another reason why these environments are so key, is because they typically have low methane emissions, which prevents that large offset of the carbon store. So just a summary of that, the two main reasons coastal wetlands store lots of carbon is because their plants grow a lot each year, that high productivity. And so they take up a lot of carbon dioxide from the atmosphere. And their soils are mostly anaerobic, so they have very slow breakdown of that carbon, and the carbon can be stored for hundreds or thousands of years. So they're really a critical natural climate solution, have the potential to reduce some of the effects of climate change. One bad thing is that given the amount of ecosystem services these wetlands provide us, they are some of the most threatened in the world. So they are threatened by, here's a picture of deforestation of mangroves in Madagascar. And this is a shrimp pond I visited in Vietnam, where the mangroves have been completely cleared for aquaculture. And so they tend to have, be threatened by these kind of things, and also by pollution. So globally so far, we have lost up to 67% of mangroves, at least 35% of tidal marshes, and approximately 29% of seagrass meadows. And if we continue with these rates in the next 100 years, we expect to see almost all unprotected mangroves lost, and a further 30 to 40% of tidal marshes and seagrass meadows. When lost or degraded, these wetlands become large sources of carbon dioxide. So not only are we losing that climate sink, we also switch into a source, so it's twice as bad. So it's really important that we get people on board and spread the message that these systems are really important. And then going on to that, thinking of some restoration projects, some good news after telling you about all of these losses. So there was a seagrass project in Virginia by the Virginia Institute of Marine Science and their partners, and they planted eelgrass because it was almost all gone in Virginia from disease and hurricanes and other things. And you'll see here, this is what they did. They were planting seeds of seagrass. And you can barely even see the acres that they seeded every year. This is this kind of tan color at the bottom of the figure. And so every spring they were just going and planting a few acres. And then this is the amount of seagrass that was growing back. So you see that the project was over 21 years and they planted 70 million eelgrass seeds over 600 acres. And it's naturally propagated into 9,000 acres. So this is a really great success story. And this is the largest seagrass restoration project in the world. And now from this, there's becoming a lot more. Mangroves also have a lot of restoration projects being done. Here's one by the Nature Conservancy in Kenya. So here you can see the mangroves of this area. And then they enlisted local women's groups to help with protecting and replanting mangroves. So here's a photo of two people planting some seedlings. Here are some of those seedlings growing in these degraded areas. And so they started this project in 2018. So far, they've planted over 61,000 mangroves across 12.5 hectares of degraded mangrove. And they have another 100 hectares that are being restored or protected from some of the illegal exploits that were making them so degraded. So these are two kind of success stories that we have. And in terms of restoration projects, I think we're going to see a lot more. We started to sign a value of the carbon in these coastal wetlands. So we have this kind of carbon trading of terrestrial systems, and it's starting to become true in blue carbon as well. So you see, especially mangroves, which tend to have a lot of restoration projects, they have a very high value per hectare. And so this allows companies to invest in restoration projects, and then they can offset their carbon emissions or they can sell carbon credits. And so hopefully this kind of adding these into the carbon market will help to increase our restoration. And so Anna also asked me to present some research that I've been doing. So I'm running out of time, and I just wanted to quickly touch on that. So some work I did last year in Quebec, so just on the St. Lawrence River estuary and a salt marsh there. And salt marshes, they typically have elevation zones that change with the height above the mudflat. And so here I'm mainly focusing on the tidal mudflat, which is flooded at high tide and unvegetated. The low marsh is flooded at high tide, and the high marsh is only flooded at very high tide. And we have this upper border that transitions into the upland. And so I measured methane emissions in these four places: the flat, the low marsh, the high marsh, and an invasive species in that upper area of the marsh. And what I saw was, when think of how I mentioned salinity, that methane fluxes were negligible from most of our zones. That's kind of what we would expect. But from this alterniflora in the low marsh, we saw very high methane emissions. And that was higher than most other values I saw for salt marshes in the literature. And there's a paper that was done that is basically looking at the effect of salinity on methane emissions. And this is what we normally expect. As we see an increase in salinity down through these marsh classes, we get a decrease in methane emissions. And above 18, so that's these really saline coastal wetlands, we tend to have very, very low methane emissions. But here in this alterniflora zone, we found emissions similar to the highest emitting marsh, these oligohaline. And so there are some big implications of this. One, showing methane emissions are elevation zone dependent. So there's high variation within salt marshes. And we saw high emissions at high salinity. That kind of suggests that our assumptions of low methane emissions in high salinity ecosystems, maybe they're not quite as resolved as we think. And so that would really have consequences for assessing the climate mitigation potential of these wetlands, how I talked about CH4 and N2O emissions, offsetting some of the carbon storage and also their carbon value. So I think I'm just out of time. So thank you for attending the talk. And hopefully that was interesting and gave you a good overview of blue carbon. And these are just some of the key resources that I used. There's 2 papers I mentioned. And then there are some blue carbon groups and a lot of websites that are really good now. So some of them is this Blue Carbon Initiative. That's different experts that come together. They have some protocols for measuring blue carbon, and Blue Carbon Partnership. And then the NOAA agency has a lot of good introductory information.
Perfect. Thank you so much for the great overview, Sophie. You really took us out to the world to give us that global scale overview. And we're going to focus in a little bit now into what's happening locally here in Barkley Sound. And so our next speakers are on the technical working group for the Huu-ay-aht First Nations Watershed Renewal Program. Our first guest is Larry Johnson, president of the Nuchalnuth Seafood Development Corporation, the current chairman of the Monmouth Treaty Fisheries Committee, and former Huu-ay-aht Director of Lands and Natural Resources, and the International Pacific Halibut Commissioner. And Larry has been integral to the successful integration of First Nations and Western resource management systems and brings a unique perspective to fisheries management issues. Larry participates in the First Nations Fisheries Council, Aquaculture Coordinating Committee, and is a member of the DFO's Indigenous Multi-Stakeholder Advisory Board on Aquaculture. And so a personal understanding of Indigenous fisheries and actively involved with treaty nations, recreational and commercial fisheries has enabled Larry to bring a unique perspective to fisheries management and aquaculture development. And our second guest is Robert Bocking, a registered professional biologist with LGL Limited with over 35 years of experience as a marine and fisheries biologist. And he's worked primarily with First Nations throughout British Columbia and the Yukon. And his work over the years has entailed fisheries stock assessment, fisheries management, treaty negotiations, treaty implementation, environmental assessment, and habitat restoration. And Bob is currently the chair of the Huu-ay-aht Watershed Renewal Program Technical Working Group and fisheries advisor to the Monmouth Nations for treaty implementation, review of major projects, and senior advisor to the Coastal Restoration Project. So both experts, we're so excited to have them join us today. Please go ahead and start your presentation.
Good afternoon. Utlama Anitsachist. At Larry Johnson. Istakshitla at First Nations. Good afternoon, everybody. My name is Larry Johnson. I come from the Huu-ay-aht First Nations. I was born in Bamfield at the old Outpost Hospital. I've as a background, I'm a fisherman, a 3rd generation fisherman. I served 10 years on chief and council for the Huu-ay-aht, and I also spent 14 years in administration. I'm here today with my colleague Bob to talk about our Huu-ay-aht Watershed Renewal Program. And you can go to the next slide, Bob. So what I want to talk about here is about our traditional territory, and what we had to do was to help Mother Earth, Nisma we call her, to recover from the past damages from logging and overfishing and development. So Huu-ay-aht have been really been adapting since the beginning of time and since contact. So for years, when I was on council, we sat on the outside of forestry watching as forestry development happened within our traditional territory. There was around 1 million cubic meters being harvested, and there we were. We had only 4 people working in the forest industry. And so, you know, with all of that activity happening, we were really only being consulted about the harvesting of trees within our territory. And so, you know, our advice, not all of it was being heard, and our values were diminishing, and as our land was suffering. So along the way, you know, we had negotiated salvaging contracts to get involved in forestry. We negotiated fishing access through the AFS agreements, so we started to generate revenue. But at the same time, we were participating in the BC Treaty Commission, BCTC treaty process. And, you know, a lot of hard work, and lo and behold, over 20 years, just shy of 20 years, we achieved a modern day treaty. So, man, that was really quite an accomplishment for our group, to come out from under the Indian Act. But we also knew that the hard work was about to start. And not to say that negotiating a modern day treaty over 20 years was no easy task. And I also believe that, for years to come, we will be fighting for our treaty and our rights for years to come. But I also believe that work like this, like the Renewal Program, we've paved the way for others to follow. And we plan on building on those successes. So when we got the treaty, our self-determination and self-governing power gave us the power to change things in our territory. I still remember when this initiative started, Bob asked me to be part of a team of professionals, some specialists that were going to come to do some work with Hued and change the way we manage our hahuthi, our land base. And so for me, I looked at the team and I was like, yeah, I'd spent a lot of time politically trying to deal with the department, deal with logging, dealing with the fact that we knew we had 35 salmon rivers and streams, but only 4 had salmon in it left. So I was excited to work with this team of professionals, and it was a real good opportunity from my perspective to bring Indigenous knowledge and combine it with science, because we look at the world today, and the world is based around science and a lot of science, and there needs to be some on the ground values attached to it, and so that's what we tried to do that. So we managed. We wanted to manage our lands like we used to in a traditional sense. So working together with this team, based on our principles that we value, I thought, wow, this is a dream team. We get to go and change the way things are going to happen on our landscape. I was excited to do this work. So we wanted to manage the watersheds like we did traditionally, with multiple uses, consistent with our sacred principles. We didn't want to go backwards into time, but we want to carry the past into the future with us. So we honor the sacred principles that guide us. And those principles are Pishuk Ma Zawak. Everything is one, everything is connected. The second principle is Isak. A lot of people just think it means respect, but it's much more than that. It's a greater respect with caring. It's how you carry yourself. It's how you want to be treated. It's how you treat people. And then the final one is Uafak, to take care of. Take care of Mother Earth and all of the resources, and to take care of it using a modern approach. So the way I like to describe our principles is like this. If you understand how everything is interconnected, and you learn how to respect it, and you take care of it, then you know what it means to me to be a Ho'et. Our identity is of who we are and what we value is founded in our connection to our lands and our resources. Our identity it comes right from our lands and our connection to our ancestors told us that we're connected spiritually to all creatures, plants, birds with whom we share life. The Creator placed us here where we belong a long time ago as stewards of the land, to maintain a balance, to take care of it so it was there for 7 generations. So we embarked on this work that we're calling a Renewal Program. We wanted to combine the Western science and Indigenous knowledge. We wanted to rebuild salmon populations while ensuring that the interconnectedness was in mind for all things like wildlife and the other values like basket grass, bark, trees, medicinal plants, animals, toads, insects. All of that makes an environment. And so we wanted to create jobs. We wanted to build capacity at the same time while building our Hued expertise as we build our world according to our principles and values. And I want to reflect just a little bit by looking back into our past. We can see that we knew that individually We all know something. We're experts at certain things. And so individually, we all know something, but all together, we know lots. This is how our community work together to achieve sustainability, to achieve a sustainable life off of our land base. And that's what sustained us for thousands and thousands of years. So we just want to be heard. We want to share our land. We want to share our resources. We want to build economies, create jobs, have healthier, happier communities. And change slides, well. So who are we now? We're a modern day treaty. We have our executive council. We have our Huet Hatwe. Under a treaty, we built our own constitution that incorporated our traditional laws with our elected systems. So utilizing our newfound governments and our advice from our Hatwe, we formed a technical working group, and the team, Bob Bocking, who's a biologist, Christine Grumman, who's with our Huet Lands and Resources, Amelia Voss on our Lands and Resources team, myself. We've had Mark Gabry for stream restoration, Bryce Bancroft for riparian and forestry ecology and forest practices, Chris Niziolomsky, forest service analysis, and Stan Coleman, who's forestry, heads up our forestry department. So now, we're a modern day treaty within the nation of Canada with self-governing rights. We wanted to build an economy. We want to bring people home. And we want to build a future while breathing life back into our communities and rising to our historic greatness, using our ancient spirit and modern mind. The three principles that will guide us, as well as the 5 pillars. So, we're bridging that gap between science and Indigenous knowledge again. So we wanted to make sure we built capacity. So we built the expertise in-house. We had to bring the expertise in, but eventually we're building capacity so that we'll be full stewards of our land. We wanted to do some research and monitoring. Previously, our history says it's all oral. Well, we're in a new modern age. We need to start collecting data. We need to start monitoring things. We need to restore watershed restoration for salmon populations. Mother Earth needs help. So, we're also the watershed management enhancement. So all that, those pillars make up our renewal of what we're driving for. I'll hand it over to Bob now. I think we're the right space here. Oh, hang on, one more slide. Next slide, Bob. Yeah, so this is the study area. It's within the core of our traditional territory. Our traditional territory goes from Coleman Creek all the way out past the Deer Group Islands and out 67 miles in our treaty world, and comes all the way down to Suziet Falls and goes inland. But a study area are the watersheds here. That's where we wanted to make the difference, to change the way forest practices are, to make sure that we're looking after our salmon, make sure that we're looking after those other attributes in the forest, because the forest isn't just trees. We have a lot of life there. So anyway, I'll hand it over to my colleague, Bob, now. Thank you.
Thank you, Larry, and hello, everybody. I'm going to spend a bit of time talking about the Western science aspects, but also interject some of the local knowledge as well that Larry spoke about. Starting first of all, back in early 2017, we were asked by the Huet people to write a renewal plan, and we started off by drafting a framework. And just quickly, this slide, if you move from the top left-hand corner in a clockwise direction, we started with taking a look at what Huet knowledge or Indigenous knowledge and values we needed to operate under, pulled in the understanding that has been gained over decades of research and work by the Huet Nation in the watersheds and understanding the processes, identify gaps, and then build a plan to do some assessments, which is this top blue blue circle here, and we're still doing these types of assessments. All of that feeds into a plan with short-term and long-term objectives for the restoration of ecosystem processes and specific high values of the nation. And then that leads into actual work around restoration, planning and prescribing, implementing those projects and monitoring them, all of which feeds back again to more knowledge, updating the renewal plan, more assessments in an adaptive management framework. And another important part of the renewal program is to also provide research and decision options out to the policymakers within the nation and other governments around resource management and how the Hahuthli will be managed into the future for multiple uses in a sustainable process. So a couple of things I'm just going to touch on one slide for each of the 5 pillars that Larry described, starting with capacity. Since 2017, we're now in our 4th year of the program. We've had over 20 Huu-ay-aht citizens employed. A good number of them have received environmental technician certification, as well as archaeological and field skills certification, and lots of on-the-job training. Some of the Huu-ay-aht workers are shown here in the photos. On the research and monitoring pillar, a whole host of activities are going on here. We're doing wildlife habitat mapping and identifying the use of the Hahuthli by a whole host of species, particularly large carnivores and ungulates. We're monitoring the effectiveness of previous stream restoration that was done a couple of decades ago, seeing how well it's doing and identifying areas for improving on those. We're monitoring escapement, which is funded in part by DFO. So thanks to DFO for funding those aspects. Monitoring the outmigration of Chinook salmon from the Sarita for the first time. We're now starting to understand what the system is producing in the way of Chinook, beyond just what's been provided through hatchery supplementation. We're also monitoring the use of the estuary by salmon of all species and other fish to get an understanding of changes over time and where we can continue to do restoration efforts in the estuary. And we're also monitoring stream flows into Pachina, which adds value to the Environment Canada and Climate Change Station on the Sarita. Under the restoration pillar, we've done some pretty exciting projects. We're restoring riparian areas, which are the lowland areas adjacent to the rivers. Logging historically went right down to the stream banks, and subsequently those areas are not what they used to be. They're primarily dominated by alder in a lot of areas, and we want to see those come back with large conifer trees to support a whole variety of things. We've been putting large woody debris into the Pachina River. We did a large project in 2020 around that. And then we've been doing some off-channel habitat restoration as well. And one thing that we'll touch on later in this talk and focus a little bit on is the estuary, where we did a causeway breach to open up areas of the estuary that were cut off by a logging road. And we're also working with Huu-ay-aht Forestry to identify priority areas for deactivating roads and improving culverts to promote salmon values in particular. And recently, we've been also working with the Association for Wetland Society on Western Toad in Frederick Lake. For watershed management, which I mentioned, we feed into other processes that the nation is involved in on the land. So we did a project to delineate floodplains to improve the protection of floodplains from human activity. We looked at wind throw, which is basically blowdown of trees adjacent to cut blocks to identify where they're high risk areas and what we can do to manage those. We looked at how much of the watershed is cut in a measure called equivalent clear cut. And we've been doing watershed assessments on a broader scale to identify where the highest risk areas for things like landslides and road failures are, and how to avoid those or repair already damaged areas. we have a project around invasive species management and also stream signage. Under the enhancement pillar, we've been working quite closely with Fisheries and Oceans Canada to enhance salmon in a variety of systems, primarily the Sugsaw and Pachina and Sarita. And a number of activities are undertaken every year. We're pretty excited about this because with DFO, we're leading the way to identify how best to manage for wild salmon genetics, as well as to meet the aspirations of the Hue people to have abundant salmon resources. So we're evaluating hatchery methods and rearing methods and coded wire tagging or marking so we can gain valuable information.
Okay, awesome. Thank you so much for your presentation, Larry and Bob. Great to see some of the efforts happening right here in Barkley Sound in the Huu First Nations territory. So we've gone from global to local, and we have a question here for Sophie. And it's just a little bit of another big picture question. What are the effects of the climate crisis and environmental changes on blue carbon ecosystems, like the mangroves and salt marshes and seagrass beds you spoke of?
Yeah, they're obviously going to be very affected by climate change. One of the big things you probably think of is sea level rise, but also increasing temperature, increasing CO2, more frequent extreme storms, and changes in precipitation. And if we just take temperature, for example, one thing you'll expect is that the tropics will expand. And so that 20-degree isotherm I showed will allow poleward expansion of mangroves, but they have higher carbon stocks than salt marshes. So maybe that's like a positive thing that could happen. And also with sea level rise, you expect more of the like the marshes and mangroves to be able to spread back into the land. And so they can have a larger area. But then also you'd expect some of them to be lost at the seaward side. So there's a lot of complex effects. And with temperature, also the carbon breakdown in the soil might increase, but the productivity of the plants would increase. So I think that there's a lot of things to be understood, and it's quite complex. But yeah, in that Future of Blue Carbon paper I suggested, they have a table with very detailed information that is kind of cool if anyone is interested in that.
Very complex. It's almost like a chemistry equation where it's you lose some, you gain some. Interesting. And Aaron from the audience is wondering, what is your opinion on macroalgae being included in the blue carbon conversation?
Yeah, I think that's starting to get some interest in the last few years. Yeah, I think that anything that's storing carbon in these marine systems should be included in blue carbon. I think traditionally it's always been thought of what's being buried, but it doesn't always necessarily have to be that. And yeah, I think we're going to see a lot more expansion of the blue carbon field. It's still pretty young, like 20 years sounds a long time, but in terms of science, it's really a short time.
Right. Yeah, absolutely. Thank you for that. And Larry and Bob, you touched on some of the restoration projects that you've been working on with large carnivores and large stream restoration. Have you noticed any changes already, and how do you sort of measure restoration success in these projects?
That's a pretty tough question. I'll take a stab at it first, Bob. But yeah, I think but in just the start of it is really important. The fact that we're doing all of these things, the measure of success will be years to come. When we're seeing plentiful salmon coming back, when we're seeing elk and deer populating our forests again, and when we start to note that in the future, 10, 20, 30 years from now, we still have canoe logs and we haven't logged everything. So all of the work that we're doing is really to try to bring the abundances back so that we can have a healthy community and share that. So take it from there, Bob.
Yeah, I'll just quickly add that, it took over 50 years to damage the watersheds, and it's going to, when I was first asked to get involved in this, I told Chief Roberts Dennis, this is a 100-year proposition to, renew it to the state it was originally. And we purposely chose the name Watershed Renewal because we don't believe that you can restore something, you know, that's so severely affected as the, you know, the watersheds in the Hawaiian territory, you know, to what they were, and that may not be the goal. The goal is to, you know, reach the objectives that the nation sets forward and that we set forward collectively, and strive to them. And in the short term, every time we do a restoration project, we have a monitoring component. And so, yes, we are seeing successes. When we breached the causeway in the Sarita estuary, we immediately saw fish use the areas that were cut off. And we continue to monitor the use of those areas by salmon.
Great. Thank you so much. I was curious about, you know, the intentional use of the word renewal. So thanks for touching on that. And I guess, you know, one of the things you just brought up was there's 50 years of damage. I'm curious what your thoughts are on whose responsibility is it to renew these ecosystems and who's been doing the damage. Could you comment on that?
I'm going to let you take this one, Larry.
Well, we probably know who's responsible for the damage, and pointing fingers probably won't really help us much here. But the fact of the matter is the Huayet First Nation, we believe we've been here since the beginning of time, and we're going to be here to the end of time. So it's always been our responsibility to look after our territories. We haven't been stewards of our land for a while. We've been giving advice about being stewards of our land. And so under a new modern day treaty, we have the self-determination and the self-governing rights to go forth and to change that world. So in my mind, we're making great strides on that. And I think, you know, we will get to our historic greatness. Thank you.
So one of the themes that's emerged and I've heard of in both your presentations was restoration and protection, kind of both of them going hand in hand. Sophie, I wonder if you could comment a little bit on which one do you think is more ecologically relevant, or where should our efforts be focused the most? And it doesn't have to be one or the other, but what are your comments on that?
Yeah, I think that always we want to protect what we have, right? And like Bob was saying, this is a 100-year project to get back to what you're thinking of. Then we always need to protect over restoring. But in terms of the coastal wetlands, and I showed all of those global losses, there's so many that we're going to have to do a lot of restoration to get anywhere near back to where we were. And I think one key thing is that when we think of restoring, you have to think of all parts of the restoration, which is a good thing that they are doing with their project. But you know, if you plant mangroves, then you can restore the kind of plant side of it. But are you restoring all of the chemistry side and that carbon sequestration and other benefits? And it can take a really long time to get the full effects to come back. And so protecting, I think, is really important at the first thing. But like I said, we're going to have to do a lot of restoration too.
Absolutely. And Larry and Bob, where do you think is where's the potential of restoration going forward? What are some of the upcoming projects within the Watershed Renewal Program that you're excited about?
Well, ones I'm excited about, I guess, is you've seen the title of the slide or the video that we plugged in later with 35 salmon rivers and streams. We've just started. You know, we're working on the Sarita, the Tlanawa, the Sugsaw. So there's about 32 more to go. So the excitement will be just carrying on with the work that we're doing and showing the world that siloed management doesn't really work that well, and that in fact Indigenous knowledge has a place with science in this world.
May I just add
ahead,
one quick other point to that? I think the fact that the Watershed Renewal Program is multidisciplinary is really exciting for me, because as a fisheries biologist, I've always understood the importance of riparian areas and restoring them for fish and salmon values. But when you're in a room and collecting the information, we are, for example, on elk, which are in the Huayet Hahuthli, they're using those riparian areas too. And so what's good for a salmon may not necessarily be good for an elk, and vice versa. And so creating the multidisciplinary approach, bringing in the Indigenous knowledge, and actually really trying to get to the heart of understanding what these ecosystems are all about is exciting too. And that will hopefully keep informing our program as we go forward.
first of all, just want to say thank you to all of our guest speakers today for the great presentations, but then also this discussion. We always learn the most through conversation. And if there's any last minute questions from the audience, please go ahead and put them in. And we'll try and forward this on to our speakers in case we can't get to them today. And what we will do, as usual, we'll end with our climate action recommendations for today. But then if you want to stick around a bit longer, we're going to go ahead and play the video that Larry and Bob had set up. And so you can feel free to stick around or leave the webinar. We'll leave it up to you. And so here are our climate action recommendations for today. So we've heard so much about the potential of blue carbon and restoration, and it's important to consider how our speakers have talked about today. Coastal restoration isn't just on the ocean. All these water systems are connected. So what kind of coasts are there near you? And are there community groups that are working to restore some of those coastal ecosystems already? So we'll link in our show notes some of the resources that Sophie put up about the Blue Carbon Initiative and some of the other ways you can get involved in your community. And then our second task for you is think a little bit about some of the underappreciated habitats near you. I think when we hear about blue carbon and kelp and corals and all these really fancy coastal ecosystems, it can be sometimes easy to forget about the fens, the bogs, the swamps. I'll leave it up to you to figure out the difference between those. But maybe there are some conservation groups locally who are working to protect those wetlands. And then finally, when we're thinking about restoration, some people are also starting to think about how can we use restoration not only to restore the lands and the waters, but maybe our relationships with nature as well and with the land and water. And so this is just a bit more of up in the air, but I'll leave that to you to reflect on what your relationship is with those kinds of environments. And is there an opportunity for you to maybe renew or restore that relationship? As a reminder, our next episode is just 2 weeks away. February 2nd, we're going to be discussing rising seas and coastal weather extremes, which we're no stranger to around the world and especially in BC. But then what are communities doing to adapt and to evolve to survive those kind of situations? So we'll see you in 2 weeks to find out. Huge thanks again to our speakers. We're going to transition now into the video, so you're welcome to stick around to watch it, or if you have to run, we'll see you next time.
Well, in the Sarita watershed right now, we have a renewal project that's going in that Bob Bocking is working on, where we have a lot of Hawaiian citizens actually working with them. And so in order for us to reverse the effects of forestry and fisheries, we need work like this.
The objective of stream renewal is to create fish habitat. So this year we're really doing the most projects that I've ever done. Hawaii kept putting in investments into fish habitat. There was also riparian assessments. So a lot of areas, they were not replanted, they were cut 50 years ago, and all you have is alder growing there. You look at some of these slopes there, it's all gravel, so once the water levels come up 5 meters, then it's all... So this is logjam that was like 60 meters long, up in certain areas 3 meters deep. So we had an excavator come in here, and he sorted through all these logs and chose the nice ones. And you can see all this is all cedar that's been lying in the creek already for 50, 60 years. It'll lie in the creek another 50, 60. We recabled some of the structures that were built 15 and 18 years ago. We built structures up here, and they kept, and some of them actually they act as debris catchers, so they catch more wood. So the idea was, for the projects we did last year, was just to recable some of the additional wood that landed on the existing large woody debris structures. And this year we're building actually 70 structures here in the Pachina watershed. So that's quite significant. There will be additional fish habitat where there's nothing that exists.
So now we're in Russo Creek, and this is the start of tributary F. This structure is one of the 70 plus structures that we placed. You can see the large logs with the boulders and the cables that help secure the structure. And so you can see with the high water levels that have come along and placed further debris on top of the structure, just goes to show how high some of this creek can actually get. Yeah, and then we've got a long support structure that goes up into the back there that possibly may be anchored to another tree. If you have a look, you can see that there's some deep pools that have been created underneath. So when the water does pick up and come through, it'll pick up that gravel, and so you get a scour pool, and it'll take it out, so then you actually end up with a deeper pool underneath the structure, which gives the hiding places for the fish and the shade and the protection that they need.
Today we're standing on some of Hoyat's treaty settlement land. We're at the north Sarita River, which is above Sarita Lake. The crew behind me is they work for Meridian Forest Services, and this project right here is to do with renewal of the riparian areas along streams. So this is part of Hoyat's Watershed Restoration project.
Where we're standing here now, next to the river, is actually what we call an active floodplain of the river. So in the wintertime and during heavy storms, all this area is actually filled with water. Essentially, it's the floodplain of the Sarita River. So one of the initiatives that Hoyat is taking at the moment to kind of go above and beyond what provincial forestry standards are is that we're actually incorporating these floodplain areas as part of our riparian reserve and management zones. They're going to be looking at things like our wind throw management strategies. So what we do to try and prevent or try to lower the wind throw risks in our cut blocks, and whether or not that's actually being implemented and whether or not it's working. Things like our riparian management areas. So how are we managing our riparian areas, and is that actually working? Is that actually giving us the benefits that Hoyat's looking for? And we've also gone ahead and marked a lot of our fish stream crossings along a bunch of the main lines. So anywhere where we have a stream that passes under the road that has potential for fish use in it, we have signage up there with the name of the stream and showing that there is fish in there, just so people keep pollutants out of there, as well as all the heavy equipment that uses those roads. So if a grader is grading that road, they know that there's fish in that creek, so they're going to try and do their best to keep all that material and all that sediments and stuff out of those fish streams as well.
Right here at Fredericton Creek, there is an old road there, and they call it a causeway. It was a straight stretch. That's what we used to call it when we lived at Cookswies. But what they done is they put 3 channels into that estuary. So now that the salmon, the young fry, have a place to go and be safe.
Standing on the old Sarita Main, where we've just completed a breach. This road was put in after 1928, I do believe. So it's been here a while, and the salmon have been not able to go on the other side of the road. So now we've got the 3 breaches in so that they can go back into Fredericks Creek, where they could only go at high water before. So hopefully we'll be able to see more fish enhancement in that area, and also up another little creek right in through here that has coho in it. So we're hoping to see the coho come back to that, and we're hoping to see the chum salmon come back into the Fredericks, and also our spring salmon and coho coming back to this river.
We've accomplished quite a bit in the first 3 years of the Watershed Renewal Program. That project is now in year 3, and actually that's a very good example of how simple things like opening up habitat for juvenile salmon that has been cut off for decades can make a difference. We're seeing those habitats used by juvenile Chinook and juvenile coho. We're getting more juvenile Chinook into the river and then into the ocean. And also the wild numbers of natural spawn Chinook have been going up steadily over the last years. In fact, this year was the largest output of Chinook salmon from the Sarita River that we've seen in the last 4 years.
The Watershed Renewal Program is many, many things. It's trying to accomplish a lot. A lot of the work that's happened so far has been in the actual rivers and in streams within Huayet territory.
The Saxon Hatchery began in late 90s. There are two different streams that we enhance, the Russo Creek and the Pachina River. Our license goal was for the Russo Creek, rebuild and harvest, and for the Pachina River, it was conservation. Over time, we've seen a good return to both those rivers. Most of that was supported by enhancement.
So we're going to be transporting our cohos into our holding tanks right now. And we got about 7 females and 6 males. And we're going to be holding them here for a couple of weeks till they're ready to spawn.
We are running a really successful salmon monitoring program. This year we were able to count salmon in 8 of our creeks and streams, and we got really good data on that. Ingrained in that is a pretty strong relationship with DFO. They help support our projects and help fund some of our stream projects. People from all sorts of walks. So you see industry, you see governments, you see the sports recreational fishery people, and they're all sitting at the same table and they're all trying to find a common goal.
It's definitely given me a bigger understanding and respect for what we do on the land and how it affects the fish.